Hi! In previous lessons, we learned about the atom, which we called the smallest indivisible particle of an element that can partake in a chemical reaction. Most substances cannot exist by themselves as individual atoms. Rather, they exist as molecules. A molecule is the smallest particle in a chemical element or compound that has the chemical properties of that element or compound and can exist as a separate unit of that substance. Now, molecules can vary greatly in size and complexity from molecules that contain just one atom like helium to very large molecules like DNA. The molecules of any particular substance are identical, meaning that they have the same mass, the same structure, the same chemical, mechanical, and electrical properties. A molecule can be made up of atoms of the same element or atoms of different elements. For example, the molecule of oxygen is made up of two oxygen atoms joined together by a chemical bond. A molecule of water is made up of two atoms of hydrogen and one of oxygen. A molecule of hydrochloric acid consists of one atom of hydrogen and one atom of chlorine. Atoms combine in simple proportions to form these molecules. Remember that we said atoms are very small particles with radii on the order of 1 angstrom, which is equal to 10 raised to the power minus 10 meters. And since molecules are made up of atoms, and most molecules do not have lots of atoms, the size of most molecules is also really small. This means that the size of a molecule is on the order of 10 raised to the power minus 9 to 10 raised to the power minus 10. This is so small that a gram of a substance can contain several million molecules of that substance. For example, a molecule of water has a diameter of approximately 2.8 angstroms or 0.28 nanometers, while DNA could be about 2 nanometers across. Proteins are examples of large molecules. They can contain thousands of atoms, and they can be up to 1,000 nanometers across, as seen in connectin. The approximate size of a molecule was given by Lord Rayleigh in 1890. He did this using the oil film experiment, which you can try at home. To do this, put clean water into a shallow, clean, oil-free dish and sprinkle some lycopodium or talcum powder lightly on the surface of the water. Then, using a graduated pipette with a fine bore, take a small volume of oil. Now note the reading on the pipette. Drop a few drops of that oil on the surface of the water and note again the reading on the pipette scale. The difference between your former reading and your current reading is the volume of the oil on the surface of the water. The oil drop should spread out, forming a clear, thin film that is pushing that powder outwards. When the oil stops spreading, you can assume that the film is 1 molecule thick. Now measure the diameter of that oil film to the nearest centimeter using a ruler. You can use this to calculate the area of the oil film, which is given by pi d squared over 4. We then use this to find the thickness of the film, which can be given by volume over area. Now this thickness represents the size of the oil molecule. Results from experiments suggest that the diameter of an oil molecule is usually about 2 times 10 raised to the power minus 7 centimeters. Now that gives you the idea of the size of a molecule. And I hope you got that. See you in the next lesson.